Hello, we're starting today's lesson on page 94. We continue practicing reading coordinate graphs or coordinate planes. So let's take a look at number 3 right here up above. So here is the formal introduction. What do we have? The horizontal axis, let's do some terminology, new terms. The horizontal axis, which is basically a number line that you're used to going side to side, is called the x-axis. As you can see, it goes horizontally, okay? Now, we also have an additional component, right, to understand the positions of objects or points is the vertical number line, and that is called the y-axis. These are the definitions that's been given by mathematicians. René Descartes, the French philosopher and mathematicians, came up with this system of coordinates, and therefore we call it Cartesian plane, based on his last name, Descartes, Cartesian plane. So it's a way for us to navigate from point A to point C and D and E and B and so on. So each of these points on this grid, right, and the square has its own, we can find it in its own unique way, but following this simple process. First, we go side to side along the x-axis, and then we go up and down. Well, in this case, only to the right now, in the right direction, and only up right now, in the positive y direction, to reach the vertical location. So which point corresponds to each ordered pair? My friends, that's new definition for you. Ordered pair is the two numbers between the parentheses listed with a comma. For example, here, 2, 3. This is called ordered pair. The reason it's ordered because we present it in a specific order. First is how far you travel along the horizontal x-axis, and then how far you travel up the y-axis in the vertical direction. So let's practice. 2, 3. Which point is this? We go 2, and then 1, 2, 3. We go up 3, and that is point E. Now let's try to read the coordinate plane without using those little rainbows that I've been creating just for our initial practice. 0, 9. So we start at 0, we don't go anywhere to the right, and we reach all the way up 9 on the number line, and that's point B. 5, 6. Again, let's travel up to 5 on the x-axis, and let's go up to 6, and we reach point C. Finally, for next point, 6, 5, the points are marked with ordered pair. Why is this ordered again? It takes two numbers, one along the horizontal axis, we call x, and one along the vertical axis, we call y. So the final number is 6, 5. So we have to reach 6, and then we go up to 5, and we reach point D. I think it's pretty easy. I hope you are visually understanding how we're traveling along the system of two number lines, one that goes in the horizontal direction, one that goes in the vertical direction. Now, we have a graph. We have more going on in this graph. Each square is 1 unit. Okay, no problem. Find the length of segments AB and segment CD. So first, let's start with AB. Here is AB. I'm going to take a highlighter because it's much easier. Here is point AB, and here is point CD. So let's find their lengths. Well, it's not so difficult to identify that point AB is line segment AB is 3 units tall, and line segment CD is 4 units, right? Which coordinate? Now, next question. The blank coordinate of the end point of line segment FD. Let's find what, just like in geometry, first let's identify what are we talking about. Here is our vertical line FD. So the blank coordinate of the end point of line segment FD are the same. Which, let's identify what do we have for FD. Well, point F is 7, 10, and point D is 7, 4. We see that they share the same coordinate on the x-axis, the x coordinate. You see here is the 7. They both share 7. They're both on along the 7th line, right, in the coordinate. Line segment FD is parallel. Oh, okay, our parallel lines. I hope you notice that this line segment is parallel to the y-axis, right? So let's label it. Line segment FD is parallel to the y-axis. We would write AD is parallel to y-axis, like that. Find the length of FD, we subtract the y coordinates. Notice how point D is a little bit lower. It's located at 4, and point F is a little bit above, right? It's vertically high up. So what would we do? We would subtract 10 minus 4, and we would identify that the segment FD is 6 units long. 6 units long. What is the distance from point C to point at 3, 18? Let me pick up a different marker. So point C is right here. Where is our point C? A, B, C. Here is point C, right? Point C is located at 3, 4. That is the coordinate for point C, 3, 4, and to a point on 3, 18. So again, we're still staying on 3. Notice how the x value is the same, right? We're staying on, we don't see this point, but we know from 4 we have to go up all the way to 18. So the difference between 18 and 4, we know that this point is 12 units away. We would need to travel from C all the way in the upward direction all the way to 18. Okay, now next question. Oh, it's a next assignment for number 5. I hope this makes sense, traveling along the coordinate plane. Next, 2 points P and Q are at the coordinates 10, 20. You know what? I typically like to label 10, 20 for P and 15, 20 for Q. Now, let's just list it like that. Point P, 10, 20, and point Q, 15, 20. Please let's recall that the first value is the horizontal x-axis and the vertical is the y-axis. Notice that the y-coordinates are the same for these 2 points. The y-coordinates are 20, right? Which means I'm going to quickly sketch on the coordinate plane somewhere like that, okay? With the 2 intersecting axes, we have to go for P somewhere like 10 and go up to 20. That's going to be our P. And then for Q, we go up to 15 and also to 20. That's going to be Q. So it's going to be a line segment that looks like this, okay? Now, P and Q are how many units apart? Well, it is 15 minus 10. We are subtracting the x values, right? We're subtracting, this is your x, and this is your y, just like I indicated above. So this is at 10, this is at 15, right? So how far apart are they? They're 5 units apart. 5 units apart. And finally, number 6. A rectangle has coordinates 2, 3, 2, 10, 6, 10, 6, 3 on a grid with 1 centimeter squares. What is the perimeter? You see, my friends, area and perimeter will never say goodbye to you, and we're definitely not saying goodbye to them. So how about this? We'll label these points A, B, C, and let's put D here. I'm going to quickly sketch the coordinate plane. My friends, in geometry and coordinate geometry, which is what we're studying right now, it is always helpful if you can quickly make a quick sketch. You should always estimate. So of course, x-axis is the horizontal number line, y-axis is the vertical, and the intersection point is at point 0. Now, for point A, we go 2 to the side and 1, 2, 3 up. This is point A. 2, 3. For point B, we're still on 2, but we go up 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is point B, right? And now for point C, we go not 2, but we go 6 to the right. 1, 2, 3, 4, 5, 6. This is 6. And we go up 10. Yes, this is point C. And for point D, we go 6 to the right, but only 3 up. My friends, 1 side, 2 side, 3 side, 4 side. We have ourselves a rectangle. What is the perimeter? Well, we know the formula for perimeter is 2 lengths plus 2 widths. So let's trace it. Let's trace it with our pencil. What is the length? What is the length? I'm going to mark a final point. This is point D. Right, what is the length? Well, it goes from 2 to 6. So the length is, let me label this. The length is 4, right? Between 2 and 6. So it's 2 times 4, right? Let's rewrite perimeter, plus what is the width? What is the width of this side? C and D. Well, we know at the very top, we have 10, right? This is a 10. This is a 10, and at the very bottom, it's at 3, okay? So this is between 10 and 3, so this is 7 plus 2 times 7. And the total is 8 plus 14, and I hope you calculated correctly. We have 24. What are the units? Well, they told us these are centimeter squares. 24 centimeters is the length of the perimeter. I hope you find this video helpful.